You know, I think I told all of you this, but the plan is what I'd like to do is go over all the chapters in section 3, which is the database stuff in our ASP.NET book. And then from chapter 5, I'd like to go over chapter 24, which is the introduction to ASP.NET Model View Controller. So there's 1, 2, 3, 4, 5, 6 chapters. All right. But I think to just kind of ease our way into this, today all I'm going to do is go over chapter 12. And we should be able to do that in an hour, probably less than that, because there's a lot of review in here. In fact, most of the chapter, not all of it, but most of the chapter is review. Things like, remember what a primary key is, etc., stuff that we've talked about in earlier classes. But there is a few new things in this chapter that are specific to ASP.NET. All right. So if you are following along, I'm on page 371. Well, I guess let me back up a page. So again, chapter 12 introduces you to the concepts and terms to talk about databases, and then Thursday we'll go into chapter 13, which shows you how to use SQL data sources and the data list control. Then a week from today we'll go into grid view, and then we'll do the details in form view, then the list view, and finally talk a little bit. I might skip chapter 17 because that's on object data sources, but at a minimum I'll go through 12, 13, 14, 15, and 16. Then we'll go back and go over chapter 24. Then we're going to start on a project, a class project using Model View Controller, and that's what we'll do for the rest of the semester. And the way I'll set that up is, you know, like, I don't know, I'm not going to give you much homework on that, so probably 3 out of every 4 days will be lecture, or else 2 out of every 4 days will be lecture. So if you look here, as I mentioned, this is introduces you to basic database concepts, so you can see the stuff that's in here. So the chapter is about 25 pages, but if you look up here, until we get to about page 388, this is all review. You should already know how tables are organized, how database tables are related, how columns are defined. We will take a second to look at the setup of the Halloween database, but you know how to query a single table, you know how to do joins, you know how to do inserts, updates, and deletes, bless you, etc. So you know how to do all that stuff. You know how to use views, because we've done that, bless you. What's new in here is stored procedures in this chapter, because we didn't do any work with stored procedures in the 147 class. So we'll look at those here. And then the stuff in the last 7 or 8 pages of the chapter, how the basic ADO.NET components work, concurrency in the disconnected data architecture, and how to work with data using the data adapter. That's all new. Does anybody know what ADO stands for? Yeah, it's ActiveX Data Objects. All right, and where ActiveX came from is when you were creating .NET applications in your toolbox, in the original toolbox that you had for example, for VB.NET. There were like 21 tools in there. And that was it. But there were actually about 300 tools that were available to you. And you'd have to go into the ActiveX data controller and add them. And you could do that. All right. That's, I think, at least where the whole thing came from. So. All right. Am I right in assuming that if you look at this table as shown here in the book on page 373, you all understand that table? You can ascertain or figure out by yourselves that product ID would probably be the primary key. And when we look in here, there are what? 1, 2, 3, 4, 5, 6, 7, 8 different fields or columns. We can't tell from looking at this how many rows or records there are, but there are quite a few, as you can see just by looking in here. All right. Remember what a primary key is? I'm asking, you remember what a primary key is? Unique record identifier. Remember, it can be as small as a single field, or it can be a combination of fields. When it's a combination of fields, it's normally referred to as either a composite primary key, or a concatenated primary key, or a combined primary key. All right. We've also last semester talked a little bit about indexes. And as they say here on the bottom of page 373, a table can be defined with one or more indexes. And an index is a way that internally your database management system can go and do querying and the like faster. Indexes are automatically indices are automatically added to primary key fields, and you can add any other index you want to add. All right. How tables in a database are related. Do you remember this? Do you remember one-to-many relationships versus many-to-many relationships versus one-to-one relationships? All right. So if I've got one table in my database and I've got 15 fields in it, first name, last name, middle name, last name, address, city, state, zip, all the goodies. All right. Plus I've got social security number and let's say employee ID number. If I put all 15 of those things into one table, there is no relationship because there's only one table. But if I decide that in one table I want all of the information and all my personal information, and in the other table I want all my work information, I could have put it into one table, but I put it in two. That's a one-to-one relationship. All right. If we've got a relationship like we'll look at in just a minute, where each row in a categories table is related to one or more rows in a products table, that's a one-to-many relationship. And the other kind is a many-to-many relationship, which isn't handled correctly or naturally, I should say, in a relational database management system, so you create join or junction tables. How about this term? I'm asking. Foreign key. Remember what that is? It's been a while since you've looked at that stuff. So again, in here, if you look, we've got two different tables. We've got a category table that's got category ID, it's got short name, and it's got long name. That's it. That's our entire category table. So we take the category ID, which is the primary key in our categories table, and we add it as a foreign key in our products table, so we're able to join those two tables together. Remember? Because we're going to be doing it again. And all that stuff, again, is explained in your book on the bottom of page 375. All right? If you like their definitions better, go with those. All right, how columns and tables are defined. Again, remember this stuff. Remember what null means. If you allow null, null means unknown. Technically, in a database, you put nothing in there. If a column is null, you can just leave it blank. You can set default actions. All right. One of the things that's going to be different in here as opposed to working in MySQL, when we were in MySQL, you would just say auto_increment, and you'd have an auto increment column. In here, you've got to do it a little bit differently, and we'll look at it, but not till Thursday. In here, you've got to go into your SQL Server view, and there'll be a thing in there that says identity, and you'll have to set the identity column. Again, by default, it'll start with 1, but you don't have to have it start by 1 if you don't want to. One place where you can do things in SQL Server where it's much harder to do them in MySQL are things like check constraints. MySQL allows check constraints, but they don't enforce them. And if you say, what does that mean? That's like, I remember reading an old cartoon. Remember back in the day, I'm dating myself, so some of you might not remember this, but Mad Magazine? All right? This guy is talking to a cop, and they're right by a sign in the town that says, speed limit 35 miles per hour, radar enforced. And the guy said, wow, you must catch a lot of speeders with that. Did that cost a lot to increment that, to implement that? And the guy says, about 50 bucks. He goes, $50? For an entire radar system? And the guy goes, no, $50 for the sign. All right. So why am I telling you that? Because what MySQL does is allows you to put in check constraints, but it doesn't check them. So you can violate the check constraints. You can say that a salary has to be between $1,000 and $50,000. But if you put in something that's out of range, it doesn't check it. See what I'm saying? It allows you to put in bad values anyway. Here in SQL Server, when you put in check constraints, it doesn't allow you to do that. Again, after you define the constraints for the database, they're managed internally by the database management system. So here's an example of some of these that you could set as shown here on page 377. All right. The only one that we've got in here that's really got any kind of a constraint set up is the product ID. And you know what that is because the primary ID says it has to be a character of 1 to 10 characters basically, and it has to be unique. All right, notice in here the image file is set to null, which means if we don't have an image, maybe it's a brand new product. We don't have a picture of it yet, so we keep it set to null. Here are some of the common SQL Server types. These should look familiar to you because they're pretty much our matches in MySQL. So again, you've seen those already. All right. Next, they go into and look at the actual design of the Halloween database. So if you could look up here just for a second, because I just want to make sure you all do understand this. You see that we have in here what? 1, 2, 3, 4, 5 relationships set up. You can tell that every table in this database, all 6 tables, are on at least one end of every relationship. Would you agree with that? In other words, line items is in a relationship, products is in a relationship, invoices is in a relationship, categories is in a relationship, customers is in a relationship, and states is in a relationship. Not only that, invoices is in 2 relationships. All right, it's on the one-to-many side between invoices and line items, meaning that one invoice can have 0, 1, or more line items. It's also on the many side of the customer's invoices relationship, meaning one customer can have 0, 1, or more invoices. All right, hopefully all that made sense to you because that's all review. But they do explain on page 378, the author says, the purpose of the Halloween database is to track orders placed at an online Halloween product superstore. The central table for this database is the invoice table. It contains one row for each order placed by the company's customers. The line items table has the line items for each invoice. The product and categories table work together to store information about the products offered by the Halloween superstore. The products table has a row for each product. All right, and the categories table has a record for each different type of category. There are more products than there are categories because every category has several products associated with it. The customers table has a row for each customer who has purchased from the Halloween superstore. All right, so as you know, the idea is that if you're going to make a purchase, you have to register or do something. Next, and again, this should be, all right, all review. They first talk about how to do a query on a single table. That line there should make sense to every one of you. That line that you see right here where I'm moving the mouse over it. Select product ID, comma, name, comma, unit price from products, where category ID equal props, order by unit price. Remember, although they show it like this, this is SQL is totally case insensitive. Sometimes you'll see books that'll have keywords like select and from and where and order by be all in caps. I did a lot of that when you took the class with me. But you can just as easily have all the stuff that's in there in lowercase. So what does this say? This says go to the products table and get me every product ID, every name, and every unit price. After you've gotten me all of them, just ferret it out and give me, make sure that the category is props. And then give me all the prop stuff, but order it in ascending order based on unit price. Does all that make sense? Remember that? Okay. And the reason I'm doing it like this is I'm not sure exactly the project we're going to do in here for Model View Controller, but the one that we're going to do in the PHP class that we're going to start on in a few weeks when we start to create a simple, fairly simple, all right, e-commerce site is only going to have a couple pages on it, but we're going to create a database for it right away. All right. joining data from multiple tables. Again, hopefully you remember this. If you want to join information from two tables, for instance, we want to join information from the products table with information from the categories table. Well, if we want to do that, they better have a column in common with one another. Doesn't have to be the same name, although usually, as in this case, it is the same name. Do you remember that syntax when you take a look up on the screen right here? This is saying go and from the categories table, grab, I think it's just a short name, and then from the products table, grab the product ID, the name and the unit price. All right, and where they match, give me all that information. So if we only did what we did previously on the other page here, notice we've got product ID, name, and unit price. But now we've got product ID, name, and unit price, plus we've got the short name that describes the category that product comes from. Does that make sense? That's all stuff you're going to have to remember. All right. Once we put information in, the chances are pretty good we want to change the information that's in there. If you remember, and this is all stuff, again, that we've talked about several times before, that we talked about DDL, which is data definition language, which is what? It's create, alter, and drop. And we talked about DML, which is data manipulation language. And that is select, update, insert, and delete. All those ring any bells? Hopefully that makes some sense to you. You remember it. And the syntax for the DML stuff that's in there is shown in your book on page 385. So again, if we want to add a new record into a table, it's an insert statement. Insert into followed by the table name. Then if you're not going to put stuff in every category like they're doing here, you list the categories in a parenthesized list, then values in each one of those values. If we have 1, 2, 3 fields up here, we need 1, 2, 3 values in our value statement. Update is update followed by the table name, set followed by the field name equals to the new value, where, otherwise it sets everything. And delete, also you want a where statement in delete. This says delete everything that has that's associated with a category food. If we leave the where off, that deletes everything from our categories table. And the author mentions that down on the bottom with the update and with the delete on the bottom of page 385. All right. Hopefully you remember what views are on pages 386 and 387. A view is a saved query. So if we do this, create view customers min as select last name, comma, first name, comma, state, comma, email from customers. If we do that one right there, and then we say select star from customers min, that's going to give us all this stuff. A view is a virtual table, meaning that it's not real. Okay. All right, this is new, so please listen up. So if you've been listening with one ear or half an ear, this is just the last 5 or 6 pages of the chapter, so this will take 5 or 10 minutes to go through. All right? Notice a stored procedure, because again, this is new. You've been warned. A stored procedure is a set of one or more SQL statements stored in a database. To create a stored procedure, you use the create procedure statement that will be shown on the next page. To use a stored procedure, you send a request to be executed. So please look up here, because this is different depending on the language you use. What this allows us to have happen, notice create procedure, and it says select last name, first name, state, email from customers where state equals @state. What that means is when the program is running, I'll have something like a drop-down list, and from that drop-down list I'll be able to choose the state I want. And it'll run the procedure based on the state I just requested. So if I run that and I request Illinois, boom, it'll give me all the last name, first name, states, and emails of customers from Illinois. But if I immediately change it from Illinois to Wisconsin, it'll immediately update the query and give me different results. Does that make sense? When you're working on that in PHP, instead of using an @ sign state like this, you use question marks. So you're going to see that because it works the same way, but the syntax is different. So again, if you want a little bit more stuff on stored procedures and you don't like my verbiage, you can look on the bottom of page 389. All right. Then, last 2, 4, 6 pages in the chapter. Please listen and occasionally glance at the screen because this is all brand new stuff. This is important stuff that you'll need to understand for the next section. The primary way that you access, as it says in here, that you access database information in here is to use ADO.NET 4.5 ActiveX 4.5 data objects. And also notice in here, they say how it works because you've got to go through some hoops in order to get this stuff to work. It says to start, the data that's retrieved from a database is stored in something that's called a data set. A data set contains everything that's in a table if you say select star from table name. If you put a where statement in there, it's everything in your results set. And this can be a join statement. All right, when the data in the control, as it says, is updated, the change is reflected in the data table that's passed on to the database. To manage the flow, there's an intermediate thing in there that's called a data adapter. As mentioned, it uses commands that define SQL statements to be issued. And the key thing in here is you need to set up a data connection for all of this stuff to work. So if you look on page 391 here, they're showing you what happens. So you request the data, basically a copy of all of the data gets copied over locally into your database. You use this data adapter and these commands to write information, to read information from and write information to the database. Then when you're done, you write it back again. Does that make sense? It's the same kind of thing that we did in MySQL, but now you're doing it, manipulating it programmatically. That's what's new. So again, if you look on the bottom of page 391, it's the same stuff I just mentioned to you. So if you do nothing else, read the last 10 or so pages from this chapter. All right. Next thing they talk about in here is concurrency. And concurrency is not an issue for us because we're all using our own copies. But imagine, again, imagine that in here what we were doing is we all were using the same database that was stored on the same server. All right? So imagine that John goes and he grabs that customers table and he wants to go in there because the contact person is in the customer database and the contact person has changed. It used to be Mark Listarge, now it's Kelly Hager. So John goes and he grabs that table and he starts making a change. All right? And unknown to him, Zach comes in there and he's going to change the same record because he noticed that there was a mistake where we had that customer's address. All right? We spelled avenue wrong. So he just grabs that. So in other words, they both have the same table open to the same record at the same time. John makes his change and writes it back. Okay? Zach makes his change and writes it back. Chances are real good John's change is never going to be shown in the database because Zach overrode his and he didn't change the name of the contact. So what you can do when you're working with concurrency is you can put locks on a table, which says if I have this table open, all right, where I could conceivably be changing the data that's in the table, what you're going to do then is you're going to lock the table so nobody else can do anything with it. And there's different levels of concurrency that you use. As it says, you can have optimistic concurrency, so the program checks to see whether the database row that's going to be updated or deleted has been changed since it was retrieved. If it's been changed, it doesn't let your change take place. It throws a concurrency exception. If it hasn't taken place, so if there is nobody making a change, it allows the change to take place. And if optimistic concurrency isn't in place, the program doesn't check. As that's what I told you before. That's called last in wins. That's the example I gave you with Zach and John. All right. Finally, if you want to, you can work, this is the last page in the chapter, so you can work without a data adapter. And when you work without a data adapter, all right, you end up using what's called a data reader. Everybody see this picture right here? A data reader is called a fire hose. You know how when you turn on, you know, if you've ever seen that when they flush a hydrant, for example, and they turn it on, the water just goes spewing out, right? And even if I come up there and I put my hands up, I'm probably not going to stop it. I might get knocked over depending on the force of the water, but I'm not going to be able to stop it. All right? In much the same way with a data reader, it only goes in a forward direction, like the water from the fire hose. So if I have a data reader, it's a read-only object. But if I've got 30 records in my database and I want to just read all 30 of them, I can use a data reader. All right? Because it's much faster. But I can't write to it, so I can't make inserts, updates, and deletes. And if I bring up the 30 records and I'm on record 6, I can't back up again and read record 5. Does that make sense? So it's read-only. All right? So what we'll do in the next class, because this only took half an hour, not even. So what we'll do in the next class is we're going to go over how to use SQL data sources. Please, and I'm saying this, please, try to at least page through this chapter before the next class. It's about 40 pages long. Doesn't mean you have to read every page and spend 2 hours on it. Spend 15 minutes and page through it and look at the examples. I don't want to do it today because if I said how many people have actually looked at this, bless you, in the last month, if I said be honest, no hands would go up, other than maybe mine, because I went back and reread it last night. All right, so we'll look at the example for chapter 13 that's in there. We're going to keep working with a Halloween database, but we're going to be talking about how to do upgrades, updates, etc., using the database itself with the ActiveX 4.5 data controls. So that's where we'll pick it up in the next class.